Welcome to a video on graphing the hyperboloid of one sheet. To graph a quadric surface, it is often helpful to look at the xy, xz, and yz traces. This is where the surface intersects these three planes. So to determine the xy trace, we'll set z to 0. To determine the xz trace, we'll set y equal to 0. And then lastly, to determine the yz trace, we'll set x equal to 0. Once we have these traces, we should be able to make a nice graph of the surface. But in this video, we'll take a look at the surface using Maple. Remember, the terms present in the equation of a quadric surface tells us what type of quadric surface we have. For a hyperboloid, notice that all three degree 2 terms are present, but when the equation is equal to 1, two of the terms are positive and one of the terms is negative. When we take a look at the traces of a hyperboloid, one trace will be an ellipse, and then lastly, the axis of the hyperboloid will be parallel to the axis of the negative variable. Notice the z term is negative and the axis is a vertical line. Let's take a look at an example. Here we should notice right away that this does fit the form for a hyperboloid. Now let's go ahead and take a look at the traces. To determine the xy trace, we'll set z equal to 0. So we'll have x squared divided by 16 plus y squared divided by 25 equals 1. And this should remind us of an ellipse. And notice that the larger denominator is under the y term, so the major axis will be vertical. And this ellipse is also centered at the origin. So a squared is equal to 16, b squared is equal to 25. So since b is 5, we'll go up 5 units on the y-axis and down 5 units on the y-axis. Notice this is scaled by 2's. These will be the endpoints of the major axis. A squared is equal to 16, so a is equal to 4. So we'll go 4 units to the right and 4 units to the left. And the ellipse passes through these 4 points. So it looks something like this. This would be the xy trace. Now let's take a look at the xz trace. So we'll set y equal to 0. That'll give us x squared over 16 minus z squared over 9 equals 1. Well, we know from our study of conic sections this is a hyperbola. So what we're going to do is construct the rectangle, sketch the asymptotes, and then sketch the hyperbola. Since the positive part is the x part, this hyperbola will open left and right along the x-axis. It's centered at the origin, and since a squared is equal to 16, we'll move 4 units to the right and 4 units to the left. And since c squared is equal to 9, c would be 3. So we'll plot a point up 3 units and down 3 units. We'll use these 4 points to sketch a rectangle. And then we'll sketch the diagonals of the rectangle. These will be the asymptotes. And again, we know because the positive part is the x part, this hyperbola will open left and right. So here's one vertex opening to the right. Here's the other vertex opening to the left. This would be the xz trace. And now for the yz trace, we're going to set x equal to 0. So we'll have y squared over 25 minus z squared over 9 equals 1. Again, we have another hyperbola. Since now the y-axis is horizontal, this hyperbola will open left and right. And since b squared is equal to 25, b is 5. So I'll plot a point 5 units to the right and 5 units to the left. Again, this is scaled by 2's. And c squared is 9, so c is 3. So 3 units up and 3 units down. Here's our rectangle. Sketch the diagonals. And now we can sketch the hyperbola. Here and here. So if we slice this surface along the xy, xz, and yz planes, the intersection of the plane and the surface would look like this. We call these the traces. And if we put these traces together to form a surface, it would be a hyperboloid of one sheet, as we see here. Let's go ahead and take a look at a dynamic graph so that we can verify our traces. Again, if we take a look at just the xy plane, we can see the elliptical trace here. If we take a look at just the xz plane, it would look like this. Again, you can see the hyperbola opening left and right. And then if we take a look at the yz plane here, again you can see the hyperbola opening left and right along the y-axis this time. This is the hyperboloid of one sheet. I hope you found this example helpful. Thank you for watching.